All right, today we're going to talk about rational functions, section 8.4. So continuing on into chapter 8. We're going to talk about now some of the differences within rational functions. A rational function can be written as the ratio of two polynomials. What's a polynomial again? What's a polynomial mean again? Many terms. Okay. So for example, this is a rational function. The graph of this function gets me what's called a hyperbola. Or some people pronounce it hyperbole. Depends.
Hyperbola.
If you look up there in the far right posters over there, there are some examples of some hyperbolas. Okay, in the top right corner, there's some hyperbolas. What we're going to focus on today is finding some asymptotes. Okay, we're going to focus on finding some asymptotes. An asymptote is kind of a line that your graph will not cross. All right, so if you look over there, the third poster down on the far right, so everybody takes a look back there by the door. Third poster down talks about some asymptotes. Notice there is a vertical asymptote. It's a vertical line. So this one has a vertical asymptote here. And then there's what's called horizontal asymptotes. Okay, vertical asymptotes are found in the denominator. So if you look right here, our vertical asymptotes are found in the denominator. We've been finding these already. Remember, because what can the denominator not be? 0. So basically when we get a problem like this, x minus 2, well, what can x not equal? 2, because why? That's where I get my vertical asymptote. So I get my vertical asymptote in the denominator right there. Awesome. And then I have my horizontal asymptote. In a function like this, my horizontal asymptote is found out front by what I'm adding or subtracting. So again, if you look down here, my horizontal asymptote says -3 because I am subtracting 3. So there I have my vertical and horizontal asymptotes. Alright. So these are when the functions are in this form. So this works for this specific form right here, a over x minus h plus k. So let's look at the first problem here. Number 1. Identify the asymptotes of each function. Describe the transformation of f of x equals 1 over x. Then graph each function. So remember, my vertical asymptotes are found in the denominator. So where's my vertical, or what's my vertical asymptote going to be here? -1. So I have a vertical asymptote at -1. What about my horizontal asymptote? What's my horizontal asymptote going to be here? 2. And then I'm going to sketch my hyperbola right there. Let's try number 2. Again, I need to find the vertical asymptote. Let's look to the denominator for my vertical asymptote. What would my vertical asymptote be here, Allie? What would you say? +1. Nice job. Because 1 minus 1 is 0. Can't get 0 in the denominator. So we get a vertical asymptote at 1. And then my horizontal asymptote is what I'm adding or subtracting, which would be 3. So I get a horizontal asymptote at 3. And then I sketch my hyperbola right there. And there you go. Yes, sir?
How do you know what corner?
That's a great question. This would be how you'd graph the typical function. If, let's say I make this negative, so now it's 1 over, or -1 over x minus 1 plus 3. Now I would change it and be the different functions. Okay, so just think about like with the graph, if it's y equals a positive x, we go upwards. And if it's y equals -x, it's downwards, kind of changes the functions. Same idea. Positive, we're going through the positives here. Negatives, we're going through the negatives that way. Good question. Take a couple seconds to try these two. Identify the asymptotes, and then we'll talk about the domain and range after you identify the asymptotes. All right, let's walk through number 3 first. First thing I want to do is I want to identify the vertical asymptote. Allie, what's the vertical asymptote? 3. Allie, what's the horizontal asymptote? 5. Nice job. So domain. Who remembers what domain means? Domain is my x values. So basically, what x values can I plug in? Now, when we talked about this, remember, the denominator can't be 0, right? So what can x not equal? 3, because that was my vertical asymptote, right? So what I'm going to state here for my domain is domain can be all real numbers. X cannot equal 3. Now, yes, that is a double-lined R. That is a symbol for real numbers. But for the domain there, we know that x can equal 3 because 3 is that vertical asymptote. So we say x can be all real numbers except 3. And now let's look at the range. What range values would I get here? What numbers would I not get, would you suppose? 5. So all real numbers. Y cannot equal 5. Why did I say Y this time? Range stands for the Y values. Domain is my X, range is my Y. Let's try 4. Joe, think you can give me the vertical asymptote? -8, because -8 plus 8 give me 0. Can't have 0 in the denominator. Kyle, give me the horizontal asymptote.
-1. Or no, positive.
No, -1. And now my domain, Katie, what do you think my domain would be?
All real numbers except x.
X can equal what? Yep. And my range, Katie?
All real numbers
Y cannot equal -1, you said? Nice job. Last thing I want to talk about here. You can use the zeros and the asymptotes of f of x equals px over qx to graph f of x. Okay. The zeros of f of x occur in the numerator. The zeros occur in the numerator. Hopefully I spelled that correctly. And the vertical asymptotes occur in the denominator. Okay, so I'm going to find some functions of my numerator and denominator. So if you look here, I want to graph f of x equals x squared minus 2x minus 8 over x minus 1. I'm going to have a function like this. The numerator I want to look to factor. So I have x squared minus 2x minus 8. How does that factor? Yeah, x plus 2x minus 4. So when I do that, I find my zeros. So what plus 2 is 0? So my zeros occur at -2 and 4. So if you look over here, I take a coordinate at -2 and a coordinate at 4. And then I want to find the vertical asymptote. The vertical asymptote's in the denominator. So if you look right here, what's my vertical asymptote going to be? What minus 1 is 0? 1. So you get x equals 1. So we get that dashed line right there. All right. Then it says the graph. You can sketch the graph. Or another good idea was y'all have graphing calculators on your iPads. Type in the function within your graphing calculator on your iPads, and then kind of sketch it based on that. But what I want you to focus on is finding the zeros and the vertical asymptote. The graph after that you can do with your iPad and the graphing calculator. Okay. But again, find the zeros and the vertical asymptotes on your own. So let's look at number 5 here. I want to identify the zeros and vertical asymptotes of each function, then sketch the graph. So in the numerator here, x squared minus x minus 12, I want to look to factor. So I'm going to look to factor it. So I factor it, x squared minus x minus 12, what multiplies to get -12, adds to get -1. positive 3, negative 4. So I get x plus 3, x minus 4, all over x minus 2. Where are my zeros located at? Zeros. Negative 3 and 4. So my zeros are negative 3 and 4. It's kind of a sketchy one there. There we go. And then where's my vertical asymptote located at? My vertical asymptote is always in the denominator. My vertical asymptote is located at 2. There we go. And if you were to graph this on your graphing calculator, I think you should get something that looks kind of like that right there. All right. 6. I want to factor the numerator down first. So I have x squared minus x minus 6. What multiplies to get negative 6 adds to get negative 3. Or no, sorry, adds to get negative 1. Yep. Just kind of gave you the answer on that one. So you get x minus 3, x plus 2, all over x plus 1. So now where my zeros located at? Negative 2 and 3. Where's my vertical asymptote located at? Negative 1. So I have a 0 at negative 2, a 0 at 3, a vertical asymptote at negative 1. And if I do my graph, ooh, I didn't quite go through there best. I guess something looks like that on that one. Jake, how we doing?
Good.
Good. Like to hear that. Think you can try one on your own, Jake?
Sure.
All right.
Sure.
Let's see what you can do here. Take a couple seconds. Try this problem on your own. All right, Jake O'Connor. You had to factor it down first, right? How do you factor the numerator?
X plus 5, x minus 1.
All over x plus 1, right? So where are my zeros located at, Jake?
Negative 5 and 1.
Yeah. Negative 5 and 1. Nice job. Jake, where's my vertical asymptote at? Do I have a horizontal asymptote, Jake? Nope, not in this one. If I were to graph it, does it look something like this, Jake? Nice job. There you go. Here's your assignment.